Harlan, look at the dashboard. Novatech is going to the moon.
Impressive trajectory. But do you know where it lands?
It's exploding. We'll have 1 million users by soon.
Let's check the growth rate. 1,500 divided by 1,000?
1.5 and 2250 divided by 1500?
Constant multiplier. This is a geometric sequence with a common ratio of 1.5.
So for the investor pitch, I need the number for month 12.
We could multiply by 1.5 11 more times, or we use the formula.
Month 1 is just A, month 2 is A times R, month 3 is A times R squared.
Notice the pattern? The power is always one less than the month.
Because we start at month 1, we make n-1 jumps.
Month 12 means 11 jumps of growth.
Over 86,000 users? Wait, I thought it would be 1 million.
Exponential growth is fast, but 1.5 isn't 2. Expectations managed. One last check. The investors want a 20% growth rate next month.
20%? Easy. We just multiply our users by 0.2.
Multiply by 0.2? That crashes us down to 20% of our size. We'd fire everyone.
Oh, right. Grow by 20% means keep the original 100%.
Exactly. You add it to 1, so the multiplier is 1.2.
Got it. Percentage is the story, R is the math. Okay, 86,000 users. But wait, the revenue sheet is blank.
Looks like we have some data recovery to do.
My revenue spreadsheets, they're all corrupted. We have a pitch tomorrow.
Don't panic. What data survived the crash?
Only month 3, 18K, and month 5, 162K. The growth rate is missing.
2 points define a line, or in this case, a curve. We can recover everything. Write out the formula for both months. T5 has 4 jumps of R. T3 has 2 jumps.
I see 2 equations, 2 unknowns, A and R.
The trick, divide the bigger one by the smaller one. Stack them.
The A cancels out. We're just left with R's.
162 divided by 18 is 9, so R squared is 9.
So R is 3. We're tripling every month. Nice.
Now plug R equals 3 back into month 3 to find our starting point.
9A equals 18, so A equals 2. We started with 2K revenue.
Double check. The middle term squared should equal the product of its neighbors.
Verified. The data is solid. I can rebuild the whole sheet.
Good, but the investors have one more question. What's the 5-year total?
The total? Like adding up 60 months? Oh no. Investors want the total revenue. M1 is month 1, M2 is month 2, all the way to M60.
We don't add one by one. We use the sum formula. First, visualize the sum as a series of bars. Now multiply the entire sum by r. Notice, multiplying by r shifts every bar's height to the next term's height.
They overlap perfectly, except the first one and the new last one.
So the difference, r, is just the first term minus the last term. Let's see that in algebra. Step 1, write S.
Now subtract S minus RS.
We are left with just the start and the end.
$7.45 million. Nice!
Alternatively, swap signs for R1. Why do investors love this? Compare it to adding the same amount every year.
Geometric growth leaves linear in the dust. That's the hockey stick curve.
A perpetual endowment. It's a special fund designed to pay out money forever.
Forever? That sounds like infinite money. We should take it, right?
Look closer. The payments are shrinking by half each time. What is the total sum S? Let's draw it as a single line. This only works if r is small, less than 1. Why?
If R, the pieces get bigger. You can't sum them up.
Exactly. If r is 0.5, they shrink to 0, fitting in a finite box. Real-world value? Pricing a preferred stock that pays dividends forever.
Infinite $5 payments? Is it worth infinity dollars?
Use the formula. In finance, the gap, 1 minus r, is just the interest rate I.
So it's finite, a simplified perpetuity formula.